those last hours of the day I wait when we're settling down. When we separate, I lose myself.
So now we have sum of geometric series. So there are two important ones. We have that, okay, so the first one is the sum of the infinite series of CR to the n equals, so this is when n starts at 0, okay? So then we have, this is going to be like C plus CR, like the one I just did, right? Up to whatever, up to infinity. So this is going to be C over 1 minus R, okay? And so this is the first case when n starts at 0. And then the second case is when n starts at some other number other than 0, but it still goes up to infinity. So then, and we still have the same sequence. So this would actually start at, when we plug in capital N, it would start at this number instead of just C, right? And then our next term would just be plus CR to the M plus 1, because that would be the next term, right? And then C times R to the M plus 2, and all the way up to infinity. So now, this would just be C times R to the M over 1 minus R. Okay, so these are two pretty important formulas that you'll probably need for calculations on homework and whatnot. Okay, so a quick example of that I will do on the next slide. So we have, let's say, so here's the example. We're asked to calculate with n starting at 3 and going up to infinity, the following sequence, like this, okay? So this, if you just write it out, that would be something like, so it would start at 3, right? And then the next thing would be, the next term would be to the 4th, and then so on and so forth, okay? So in this case, our M, our capital M, equals 3, our C equals 6, and our R equals -1/2. Okay, so we're just going to plug this into our formula, and we get that, so C times R to the M over 1 minus R equals 6 times R to the M, which is 3, over 1 minus R, which is -1/2. So then we get that the top is 6 times -1/8, right? And then on the bottom we have 1 plus a 1/2, which is 3/2, okay? And then if we simplify, we're going to get -6/8, and then I'm just going to multiply times the reciprocal here. So then this cancels here. We have a 4/8, so this equals -1/2. Okay, so that would be the sum of this infinite geometric series. All right, now for the last concept, and this one's pretty important as well, as is everything else. So this is called the divergence test. Divergence test. Okay. So I'm going to write the formal definition because that's pretty important. So if an, the nth term, not the entire sequence, okay? So if the nth term does not converge, and not only does it not converge, but it has to converge to 0. So if it does not converge to 0, I'll write it as a number for emphasis. Then we can say that the infinite series of an diverges. Okay. Okay. So we can use this. It's kind of just a statement, and then here's how you would apply it to an example. So let's say we're given that S equals, so this is the infinite series, n equals 1 up to infinity, and then we have n over 2n plus 3. So for this problem, we're going to prove divergent. Divergent. Okay, so first of all, we're going to we have to kind of prove the first part to conclude the second part, right? So we have to find the if. So we're going to find out if the nth term, so an, actually does converge to 0 or not. So as n goes to infinity of an, so an, and this is our an, right? So I'm just going to plug that in. So n goes to infinity, and then n over 2n plus 3. And then when we, I'm going to divide by 1 over n on top and bottom. So then the top we just get 1, right? That makes it simpler. So then we have 1 over, and then down here we're going to have a 2 plus 3 over n, okay? And then when you plug in infinity, we get 2 plus 3 over infinity. This 3 over infinity goes to 0, and we get 1/2, which typically is good. That's fine. But, so that means, since we got a finite value, that means it converges. So this converges, which is great. But according to the divergence test, because this doesn't converge to 0, so since 1/2 does not equal 0, obviously, then according to the divergence theorem, the series that we had diverges. Okay, so that's pretty important. All right, so that does it for the concepts video, and I'll talk to you later if you watch the homework video.